This is the 2014 AP Calculus AB free response question number 3. It states the function f is defined on the closed interval from -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be the function defined by g of x equals the integral from -3 to x of f of t dt. Part A asks us to find g of 3. We are given a function that is defined graphically, so we must find the area under the function. Remember that the basic definition of the integral is the area under the curve. So first let's write out the integral. This integral will be from -3 to +3 of f of t dt. So we are looking at the area of the triangles from -3 to 2 and from 2 to 3. So that would be the area of the triangle, so 1/2. The base here is 5, and the height is 4, plus 1/2. The base here is 1, and the height we do not know. So we can approximate the height to be around -2, but to make sure we can find the slope of this line. So by taking the point 0, 4, and 4, -4, we find that the slope is equal to -2, and using point slope form, we can find that y equals -2x plus 4. So at the point x equals 3, y is equal to -2. So if we plug in -2, we get 10 minus 1 equals 9, which is our value for g of 3. Part B. Part B states on what open intervals contained in the interval from -5 to 4 is the graph of g both increasing and concave down. Give a reason for your answer. So first we must find the relationship between g of x and f of x. We are given that g of x is equal to the integral from -3 to x of f of t dt. So by the fundamental theorem of calculus, if we take the derivative of g of x from -3 to x of f of t dt, we should get f of x. So therefore, the derivative of g of x is equal to f of x. So using this, we can see where the graph of g is increasing. So the graph of g is increasing when g prime of x, or f of x, is greater than 0. So if we look at the graph up here, we can see where g prime of x, or f of x, is greater than 0. So that would be everywhere that it's positive. So from -5 to 2. But there's a second part to the question. When is the graph of g concave down? So the graph of g is concave down when g prime of x is decreasing. So g prime of x is decreasing when f of x is decreasing. So let's look at those intervals. So from -5 to -3, and from 0 to 2, g prime of x is both positive and decreasing. And that gives us our answer. From -5 to -3, and from 0 to 2, g prime of x is positive and it is decreasing. So that would be both increasing and concave down for the graph of g. Part C states the function h is defined by h of x equals g of x over 5x. Find h prime of 3. So to do this, we must take the derivative using the quotient rule of h of x. So that will be the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function, which in this case is 5, all over the bottom function squared. And this is when x is equal to 3. So g prime of 3 is going to be equal to f of 3, as we found in part B, because g prime of x is equal to f of x by the fundamental theorem of calculus. So f of 3, as we found in part A, was -2. So therefore, g prime of 3 is equal to -2. So the top part is going to be 5 times 3 times -2 minus g of 3 we already found in part A to be 9, so 9 times 5, all over 5 times 3 squared. So if we simplify this, we get -30 minus 45, all over 225, which becomes negative 75 over 225, which is equal to negative 1/3. So h prime of 3 is negative 1/3. P is defined by p of x equals f of x squared minus x. Find the slope of the tangent line to the graph of p at the point where x equals negative 1. So we have to take the derivative of p of x because slope means derivative. So p prime of x is equal to f prime of x squared minus x times 2x minus 1 by the chain rule. If we plug in x equals negative 1, we get f prime of 2 times negative 3. F prime of 2 is the instantaneous rate of change at the point x equals 2. So f of 3 is equal to negative 2, and f of 1 is equal to positive 2. So if we do f of 3 minus f of 1 over 3 minus 1, we get negative 2 minus 2 over 2, which is equal to negative 2. So f prime of 2 is equal to negative 2. So now we have to multiply them. Negative 2 times negative 3 equals positive 6. And that is the slope of the line tangent to the graph of p at the point where x equals negative 1. So let's go over the scoring guidelines and common mistakes for 2014 AP Calculus AB question number 3. So for part A, you were awarded 1 point for the correct answer, 9. A common mistake one could make was forgetting to subtract 1 and instead adding it. But since 1 is an area of a triangle below the x-axis, we have to make sure to keep it negative. For part B, you are awarded 1 point for the correct answers, and you are awarded 1 point for the reasoning. The reasoning is that g prime of x equals f of x is positive and decreasing on these intervals, so that's why the graph of g is concave down and increasing. For part C, you are awarded 2 points for correctly finding the derivative of h of x, and you are awarded 1 point for the answer. A common pitfall for this question would be incorrectly using the quotient rule or incorrectly plugging it in. For part D, you are awarded 2 points for recognizing that the slope meant the derivative of p of x, and you are awarded 1 point for plugging in the numbers and finding the answer. A common mistake would be forgetting to notice that the slope means the derivative,